Okay. We're going to work forward with addition and subtraction, but before we do that, we're going to go forward on some multiplication that's in two separate locations. So rather than it all being underneath one square root, it's under two square roots. Now, we did some of this in the last class session, okay? Because I told you you can either reduce it ahead of time or you can multiply it all together and reduce it later, okay? Do you remember how to do this? Okay, the only thing that I can do on this first one would be take that x squared out, okay? So I can write that as x on the square root of 10y. And then this one, I can take the 4 out and I can go 4 on the square root of, actually it's not 4, it's 2, because the square root of 4 is 2. Oh, and I can take a y out and leave a y underneath, right? Can I do that? Then I'm going to multiply what's on the outside together, and I'm going to multiply what's on the inside together. And then I got to check it again, see if I can take anything else out. So how about the square root of 100? 10, okay, it comes out even, 10. So out here I have a 20, okay, I can't do anything with that x, so that x stays underneath. How about that y squared? It's y, right? But I already have a y out here, so I have to multiply the y times the y, so that's y squared. Okay, makes sense? All right, that was just a refresher, okay, because you're going to go on with something like that. How about division? Let's say I have the square root of 25 over 16. Okay, no letters here, just numbers. That is the same thing as saying the square root of 25 over the square root of 16. Don't make a decimal out of it and then try and do it. Okay, look at the top, look at the bottom. What's the square root of 25? 5. What's the square root of 16? So there's your answer, 5/4. Okay. How about variables? What I can do is I can reduce it first because they're both underneath the square root. Okay, if they're both under the square root, I could write it like that. What's b to the 4th over b to the 3rd?
B.
Just b. Can I take the square root of b? No, I'm done. Okay, you with me? Okay. What, however, if I had this? Whole different ballgame, because I can't reduce it first. So what do I get on the top?
B squared.
B squared, and it's underneath, I don't have a square root on the top anymore. Okay, what about on the bottom?
A squared, it's under square root.
A.
Okay, it's a on the square root of a. Okay, now, you cannot leave this like this. You are breaking math law if you leave this. The math law says you cannot have a square root on the bottom of a fraction. Now, I don't know who made that law, but that is math law. So I have to do something to get rid of the square root on the bottom. What can I multiply that bottom by that's going to make that square root go away? Any idea? That's the same thing as multiplying by 1, right? So that's perfectly legal, okay? If I multiply the square root of a times the square root of a, what do I have? Right? Don't I have the square root of a squared? What's the square root of a squared? A. And the square root's gone. So I have this right here is equal to a. So I have a times a, which is a squared on the bottom, and on the top, I've got that. Now I'm allowed to have a square root on the top. I just can't have a square root on the bottom. It is against the law. Okay? Let's do another one. I've got that. Okay, I've got a bit of a problem right here. Does it look like I can do anything? Absolutely it doesn't, okay? But I'm breaking my law. I can't have that index with a root on the bottom. This is a fifth root. So I gotta figure out what I'm gonna multiply this by to get rid of it, okay? Now, the variable is easy. So it's gonna be the fifth root of something, is it not? Okay? And I'm gonna have to multiply it by the same thing. Now, how many s's would I need to get rid of the root on the s? If I've got two of them, how many do I need? I need three more, don't I? Because I'd have to have s to the fifth power to get rid of a fifth index. So I know this is gonna be s to the third power. Okay, because s squared times s cubed is s to the fifth, and it's going to be gone. But now I got to worry about that 4. Okay, so I'm going, okay, what can I multiply that by to get rid of the fifth root? So I'm going to come over here and I'm going to go 2 to the fifth power. Okay, and this might be what I need to do, is I can go 2 to the fifth power would be 2 squared times 2 cubed, wouldn't it? Yes, no? Isn't that 2 to the fifth? And you're going, where did I get the 2 squared from?
The 4.
The 4. If I write the 4 as 2 squared, then I know that I'm going to have to multiply this by 2 cubed, because that's going to give me 2 to the fifth power. Y'all with me or not? Joseph, you're with me, okay? That's 8, is that not? 2 to the third power, it's 8. So if you want to look at it as 8, you can do that. But I think it's easier if you'll turn around and go, that's the same as 2 squared. Okay, now when I multiply, okay, now remember, I got to do top and bottom have to be the same because I'm multiplying by 1. All right, so on the top, I've got the fifth root of 3 times 2 cubed times s cubed, okay? Because all I did was multiply what was underneath it. Then we'll worry about that in a minute. Okay, on the bottom, I have the fifth root of 2 to the fifth power times s to the fifth power. Yes? No? Vivian, yes? Okay, now let's look at the bottom. What's the fifth root of 2 to the fifth power? 2. What's the fifth root of s to the fifth power? S. So at least I've done that part. I've gotten rid of the roots on the bottom. So then I go on this top and I go 3 times 8 is 24, right? Can I break that down into anything that I can take the fifth root of? Well, I would have to come over here and look and go, all right, 2 to the fifth power is equal to 2 times 2 times 2 times, what's 2 to the fifth power? Somebody tell me.
32.
32, okay. Well, if this is 32 and this is 24, then I know I'm not going to be able to do anything. Okay, I can't break 24 down into something that's smaller than the smallest thing I can take the fifth root of. Okay, so this is just going to have to stay. You can leave it just like that, or you can write 24s cubed. It's the same thing. Okay, a little bit more confusing. You got to really think that thing through. Most of the time you're not working with fifth roots, but understand if you are, I need to have something on the bottom that's going to cancel out that fifth root. Let's do another one of those. I always forget to start my timer. Let's do this one. All right, gotta get rid of that root on the bottom. So now I gotta think. Let's look at the number. What would I have to multiply that number by to get it to be something that I could take the square root of? 2, right?
Mhm.
Because 2 times 2 is 4, and I can take the square root of 4. So I know it's going to be a 2. How about that k? What do I need that k to become? So I can,
Squared.
I need it to become k squared. So I need 1 more k. What do I need that n cubed to become?
And to the fourth.
Into the 4th. So that I can take, see, Joseph's with me. I'm not sure you 3 are. You're looking at me kind of weird, okay? So I would need 1 more n. Because to be able to take a square root of this, I would need it to look like this. I'm thinking ahead. I'm thinking ahead. What can I take an even square root of? If I have a 4, that's 2. If I have a k squared, that's k. If I have an n to the 4th, that's n to the 2nd, and my square root's gone. So then I go, how do I get from here to here? And that's how. Okay? 2 times 2 is 4. K times k is k squared. N times cubed, n cubed is n to the 4th. Okay? So that's going to give me top and bottom that. Now, on the top, don't mess up. This is on the outside, this is on the inside. I can't do anything to that. I just write it. Okay, I can't do anything else. On the bottom, though, I'm going to have the square root of 4k squared n to the 4th, which then I have 6. And on the bottom, I have 2k n squared. Can I do anything else? These are all multiplied together, right? These are monomials. So therefore, if I can reduce any part of it, I reduce it. 6 divided by 2 is what? 3, and it's a 3 on the top. So my final answer looks like this. How come I can't reduce that k or that n?
Inside of the root.
One's inside, one's outside. I can't do that. Okay, so if it's inside, it's got to stay inside. If it's outside, it's got to stay outside, and I can't put those two things together. Okay? All right. Kind of makes sense? It's weird. It's different. Let's do one more. And I'm going to have you do this, just on a piece of scrap paper. Okay. All right. Simplify this problem. That's what it would say. Simplify. Which means get them out of math jail. Reagan, if you hear that camera, let me know. Because like I said, I didn't set my timer.
Mm-hmm.
Make sense? The temptation is to look at that 35 and go, "Oh, how can I break it down?" But there's nothing you can do about it. You know, and 5 and 7 is going to give you 35, and neither 5 nor 7 can be broken down. Okay, does that make sense? sort of, kind of. Practice. Practice will help us get better, okay? All right, we're
So if
gonna
you
go.
did break it down when you multiply the 4, say it's 25, you multiply the 4 by the 5.
If you could pull the 5 out, you know, you have to be able to pull it
Mhm.
out from underneath the square root to multiply it by the 4. So let's say that was 40. Okay, if that was 40, that's the same thing as 4 times 10, and I can take the square root of 4, so it would become 8 on the square root of 10x on
And
the
you don't
top.
multiply it by the bottom.
No, you don't have to multiply it. I mean, I'm not changing anything. I'm just renaming that.
You don't multiply the 4 by on the bottom.
No, the 4
Okay.
is the same as over 1.
Okay.
Okay, if you look at it as over 1, it's not distributed to the top and the bottom. Okay? All right, we're going to move on to addition and subtraction. Now, with addition and subtraction and square roots or cube roots, I want you to think of the roots as being kind of like a variable. Okay, now you're going to see what I mean in just a minute. Okay, let's say I've got this. All right, I have to break down each one of these. Now I can't combine these together because there's addition and subtraction. There's not multiplication here. Different rules. So I'm going to look at each one of them individually. Okay, square root of 20. What can I multiply together to get the square root of 20?
10 and 2.
Do what?
10 and 2.
Can I take the square root of either one of those? No. Is there anything I can multiply to get 20 that I can take the square root of?
4 and 5.
4 and 5. So that's where I want to look at it. So what is the square root of 4?
2.
2. So I go 2 times 2, which is 4. 4 on the square root of 5. Are you with me on that? Or do I need to make that center step? Okay. We're okay? All right. Looking at 45. What can I multiply together that I can take a square root of 45?
9 and 5.
9 and 5. Obviously, guys, you got to know your multiplication facts to do this, okay? So 9 and 5, what's the square root of 9?
3.
3. So I go 3 times 3, which is 6, on the square root of 5. So far, so good? Do I need to do the center
Wait,
step?
where'd you
I
get
think,
six
okay,
from?
hold on.
Yeah,
I'm going to do
so
the center step. I'm going to do the center step, okay? Once you get it in your head, you won't need to do it. Okay, so I did that.
Right.
Then I did this. What can I multiply to get 80 that I can take a square root of?
8 and 10.
Okay, I can do 8 and 10 if you want. Okay, so I have 3 on the square root of 8, 3 on the square root of 10. I'll have to break those down a little bit more in a minute. Okay, I can come over here. What's the square root of 4?
2.
2. So 2 times 2 is 4 on the square root of 5, right? What's the square root of 9? 3. So 3 times 2 is 6 on the square root of 5. Then I come over here and I can't break either one of those down. But I can write them different. What can I write the 8 as?
4 and 2.
4 and 2. So I can go the square root of 4 times the square root of 2 times the square root of 10, right? Okay, so gonna keep bringing this down. What's the square root of 4?
2.
2.
So I have 6 on the square root of 20. Can I break 20 down?
5 and 4.
5 and 4. Which I'm going to go ahead and just do that. So it's 12 on the square root of 5, right? Okay, you with me?
Oh, yeah.